All right, good morning. So this is for my Calculus 2 class. We're going to be doing some triangular substitutions here for integrals. So the first problem we have on the list today is going to be something like we have the integral of dx over 4 minus x squared, all raised to the 3/2 power. Okay, so here's what you do is you said, well, if there's a square root in this thing, generally you're looking at something that's going to require some kind of a triangle substitution. The square root is, especially the square root with a squared, like this feels like something that came from a Pythagoras theorem kind of an idea. So that should suggest to you that maybe a triangle might be involved. So the way I do this, I always like to draw the triangle just because when you go to do back substitution, having that triangle there kind of helps you go back to it. And because a squared plus b squared being c squared, that's one that I always like, okay, if I have an a squared plus b squared, that's my hypotenuse, that's not a big deal. But for this one, I just off to the side, right, b squared equals c squared minus a squared, just to make sure I get the right things in the right places. So I know my c is going to be, or c squared is going to be 4. So this is my c squared. And then my a squared, just because you could have said b squared, it's fine. Generally, when you're setting these things up, you want to favor your sines and your secants, because the derivative of sine is cosine, and the derivative of secant is tangent, secant tangent. So there are no negative signs. If you say, well, I would like to use cosines, like great, the derivative of cosine is negative sine, so that's more of an issue. So let me get to it. So I'm going to go ahead and just draw a standard right triangle off to the side here. My c squared is going to give me 2. My a is going to give me, actually, I'm going to put this over here, x, because like I said, I want to favor the sign. And then what's going to be left is going to be 4 minus x squared. Right? And the best thing about doing this is like, well, if I messed up and I don't like the way I have it, I could just swap the two sides, rework the problem, and I have a slightly different set of trigonometric ratios to have to deal with. Okay, so I'm going to put my theta in there, and then I'm going to go off to the side here. I'm going to say, okay, well, my sine of theta is equal to x over 2. And then I'm just going to go ahead and simplify this a little bit so I have a clean derivative to take. So we have x equals, and I have 2 sine theta. I just cross multiplied sort of. And then we have to take a dx. Every time you make a substitution in calculus, you have to say x equals or let u equal, and then du right after that, because it's one of those things where you really are going to need the derivative of the substitutions you just made. But this is going to be 2 cosine theta, right? Now, this one, when I'm looking for this, I've got like, this is a hypotenuse and an adjacent side to it, okay? So I'm going to go ahead and say, how about secant theta equals 2 over the square root of 4 minus x squared. Now, that's not quite what I have. I've got my 4 minus x squared here on the bottom, but I don't have just the square root. I've got this to the 3rd power. So what I'm going to do is I'm going to go ahead and raise both sides to the 3rd power. There's a cold sweat that runs through me because of secant cubed. Okay. But let's see if that goes away in any way, so I don't actually have to deal with integrating secant cubed. Okay, but this is equal to 8 over 4 minus x squared raised to the 3/2 now. And all I'm going to do is just multiply both sides by 1/8. So I'm going to get 1/8 secant cubed equals 1 over 4 minus x squared raised to the 3/2. Okay. And now when I'm looking back at my integral here, okay, we have dx over this 4 minus x squared 3/2, and we're just integrating this. Now, I was thinking this brick by brick. We're just going to substitute each of these pieces with the pieces that I already have. For my dx, we're going to say, okay, dx is going to be 2 cosine theta. Okay, and then I've got a 1 over 4x squared to the 3/2 on the bottom. This is really, I could say this is also times, yeah, times dx here. So we just plug in my dx was 2 sine theta, sorry, 2 cosine theta. The 1 over 4 minus x cubed here, that is going to be 1/8 4 minus x cubed. Okay, so this piece here, okay, is really just going to be 1/8 secant cubed theta. I already have my d theta because that's for my cosine. Okay. And now we can clean this up a little bit. 2 over 8, that's going to be a quarter. So we have 1/4. So cosine and secant cancel. Okay, so thank goodness. So we end up with a secant squared here. And already I'm looking at this like this is not going to be as bad as I thought was going to happen over here. And then, okay, we still have to integrate this. How do we integrate secant squared? Secant squared, that's just tangent. So we're going to end up with 1/4 tangent. How about tangent? Not like tangent spelled with a theta. Okay, so we just have tangent theta. There's a plus c over here. Now I'm going to go back to my triangle and say, okay, what does my triangle say? Well, let me look at tangent. Remember, tangent is just opposite over adjacent. So that's going to be x over 4 minus x squared. So we're going to have 1/4. And then we go back up here, opposite over adjacent, x over 4 minus x squared. All right, and that is going back to the original piece that I have, plus c. I'm going to go ahead and say, I'm going to call that good. Right, I'm going to try to make this video short, so I'm going to go ahead and stop this one here, and I'll put up the next one shortly. So thank you very much for tuning in. Good luck with the test, everybody, and you don't have to do this exactly the way I did it to get credit for it. Okay, I know a lot of people like to do substitutions rather than draw out the triangle. I like to draw out the triangle because it helps me with the back substitutions and it helps me make sure I've got all the pieces, all the bricks are in place. When that substitution happens, I can just go piece by piece and replace it piece by piece. Okay, make sure it happens. Like I said, good luck, everybody. Tune in next time. Oops.